6. So now when this is 6, I need to know what the y is, and I can get that just by using Pythagorean theorem. So off to the side, I need to figure out y so that I can plug in for x, y, and the dx dt. So 6 squared plus y squared equals 100 squared. So that's 36 plus y squared. Oops. All right, equal 10 squared, which is 100. Y squared equals 64. Y is an 8 when x is 6. So now I can substitute in, and it's a little bit of simple algebra. So 2 multiplied by the 6 multiplied by the rate that x is changing is 1. 2 times by the y times by the rate that it is changing. So 12 plus 16 dy dt equals 0. Doing the algebra, I'm going to subtract 12. 16 dy dt equals negative 12. All I've got to do now is divide by 16 because it's being multiplied here. Dy dt equals negative, let's see, 3 goes into there 4 times. No, 4 goes into there 3 times. Negative 3/4, and I got to put a label on here. And it's the whatever the units are per time. And these were in feet per second. And let's take a look. Remember why this is coming up negative? Remember, if the derivative is negative, that means the original value is decreasing. So, and that makes sense of the problem because the y value, the y side of my triangle, is shrinking as this bottom of the ladder gets pulled out. So it's dropping at 3/4 of a foot per second when x is 6. Okay, try another. The length of a rectangle is increasing at a rate of 8 centimeters per second, and the width is increasing at 3 centimeters per second. So they're changing at different rates. When the length is 20 centimeters and the width is 10, how fast is the area changing? So our picture is just a rectangle with an area formula. So I'll use L and W so that I can keep length and width separate. L, W. Remember, no numbers go in here, not the 20, not the 10. That's get saved for later. And then I want an area equation. So area equals length times width. So after you've got your equation, you do your rate equation, which is derivatives. So our rate equation, derivative of A is 1, times by its rate with respect to time, dA dt. Over here, just like earlier, you have to do product rule. Because each one's a variable, they're multiplied. You don't just do derivative times derivative, you have to follow product rule. So it's the derivative of the first term, which is 1, times by its rate, dL dt, times by the v term, which happens to be a w, plus, keep the first term, times by the derivative of the second term, derivative of w is 1, times by its rate. Now, if we look, for me to solve this, I've got to substitute in dA, well, what am I trying to, one of these I'm going to be solving for, but dA dt, dL dt, w, L, and dw dt. Let's see what they gave me. The length of the rectangle is increasing at a rate of 8 centimeters. So this is dl dt. So dl dt is 8. And the width is increasing at 3 centimeters per second. That's dw dt. That's a 3. The length is 20, so that's L. So substituting there, carrying along the 1. And then the width is 10. W is a 10. And then equals, we're looking for how fast is the area increasing. We're looking for dA dt. So that stays. Now it's just a matter of cranking through this. 80 plus 60 is 140. Now we need units, and this is area with respect to time. So if my length and width were in centimeters, my area is going to be square centimeters per second. So it's growing at 140 square centimeters per second. Okay, these aren't too bad, just take your time. And we'll go with one more. If a snowball melts so that its surface area decreases, that'll come into play, at a rate of 1 square centimeter per minute, find the rate at which the diameter decreases when the diameter is 10. So let's get ourselves a snowball. Okay, and then we're doing surface area, right? Surface area. So surface area of a sphere. Again, if you don't remember from geometry, you have technology that will say ask for the volume of or the surface area of a sphere. It will come up with 4 pi r squared. Now, normally you'd probably jump right into this, but the trick that's making this one a little bit challenging, if you look at what we're trying to find, it's the rate at which the diameter decreases. I need to have this formula with diameter in it, not radius. And we can do that. If I call the diameter a length of d, that means I can just rewrite the radius as half d. So the radius is technically d divided by 2. So I'm going to rewrite this equation with d divided by 2 squared. So my surface area equation is 4 pi d divided by 2 squared. So you got to have a little bit of foresight to see what you need in your equation. All right, now we're ready for the rate equation. Okay, it looks like but surface area is just one variable. I mean, even though I've got S and A there, maybe I should just change it to A so it's not confusing. So now ready for derivative. So our rate equation with respect to time. Derivative of A is 1 times by the dA dt. And again, this is 4 pi. That's like a number carrying along. It's just, don't worry about it. It's not a product rule or anything strange. Oh, I probably should take care of this, though. I think I will. I'll make this d squared. Oh, sorry about this. D squared over 4. So then I don't have to do a little power rule here. D squared over 4. Then it'll be a little bit easier. So it'll be 4 pi times, and then this will be 2d over 4 times by its rate, d diameter with respect to time. Okay, doing a little simplifying, I can cancel my 4's out. So to clean this up, before I substitute, dA dt equals 2 pi d times derivative of d with respect to time. Okay, now let's see what's given. So we've got the surface area decreases at a rate of 1 square centimeter per minute. Decreasing means I've got to put a negative on this rate when I put it in my equation. So dA dt is going to equal -1, and the diameter is 10. So now if we substitute these two values in, so dA dt is your -1, 2 pi, the diameter is 10, and then our rate that the diameter is changing. Okay, well, this is going to be 20 pi, so I'll divide by 20 pi. So again, I don't have a calculator here, so I'm just going to leave it as this fraction. Don't forget a label. So the units on diameter are centimeters per minute, because it's a rate. Okay, your assignment is going to be on the worksheet that I give you, problems 2B, 3, 5, 6, 7, 10, 11, and 14 on the worksheet. Okay. This one.